Yeah, long time no see. It has been fucking a lot things to do, so I really didn't have a time for making new content, but now we are trying to make a video about BEOMASTER amplifier or head unit or whatever you want to call it. And it is not mine unit, it's my friend, and there is under the cover a fuse which has been blown. It was that one, that fuse, and my friend replaced it and tried to turn the amplifier on, and the fuse blew immediately again when he tried to push the power button to turn amplifier on. So there is two separate outputs from the transformer. One output is giving the continuous power, so the main voltage goes in the fuse and the filter to transformer and then goes back to negative terminal. So transformer is always on and it is generating that power, which has its own fuse, and then it generates the AC voltage negative, then it is minus 13 or 16. I think somewhere is, yeah, there, 13 volts, negative 13 and positive 13. And the power is switched to amplifier unit with the relay here, and that relay is turned on when the push button is pressed here, and that relay gets its power through that full bridge rectifier thingy. And because the fuse blow only when you try to turn unit on, so I don't believe that fault is there, because the fuse blows only when the relay is connected. So perhaps there might be a problem, and we are trying to trace down where it is and try to measure if it is faulty or is it something else. And unit is already kind of opened, so it is really easy to get the cover off. Perhaps I will take it fully out, so I won't break it meanwhile working in the unit. And under here is the fuse, which is that input fuse, what burns when you try to power unit on. And there is the outputs of the transformer, and as you can here see, and we have that image too, the two wires from the transformer is going the fuse and full bridge rectifier unit, and it is here and here, the green wires what are going there, and there is that fuse, and that black thing there is that rectifier. And the another power here and here is going to through the relay to another bridge rectifier. So it is the brown and the black wire, and it is going there. There is relay 1, and I assume that the another rectifier is there. But it is kind of fucked up. Try to measure anything in here, because you can't measure through the transformer wires, because the relay is between the diodes and the transformer leads. So we have to be somehow more clever way to try to find the spots where we can try to measure the components. D2. Yeah. But there is two big capacitors, 10,000 microfarads in series. What might be those ones? And rectifier that point, which is negative output of rectifier, goes directly to condensators, capacitors. And positive lead, positive output, because the diodes are both to left, so the output power is going there, and it is also going straight to capacitors. So there should be positive voltage going there. So we might have a possibility that the caps is bad, shorted out, and that's why we are taking too much power and below the fuse. Or then the diode rectifier is itself broken. really interesting design. Yeah, 10,000 microfarads. And the red and the blue is plus and minus there and there, and that black one middle of the capacitors are going negative terminal to transformer. So it is our amplifier negative point of circuit what we are using to generate the amplified sound. So if our negative point is there, then we could have a negative 13 volts and a positive 13 volts. But let's try to first measure the gaps. Are either of those gone to shortcut? Shorted. How I say it. Let's try first just one, which is there. And it looks like it is okay, because the reading is continuously rising up. But how is our another cap doing? For me, it look like a normal behavior. I'm not worried at all. And maybe I'm able to measure that. Or then it is too much for my multimeter. Yeah, it is too much. It can't show it. Yeah, but there. That is not good. That is basically dead short. We can try the diode range. Yeah, 0.001. And that reading is between the plus and the minus. So in the paper we are measuring resistance basically here to here or there to there, and because the reading is that low, it might have two possibilities: that either we have a bad diodes shorted out in the diode rectifier, or then we have a short somewhere inside the amplifier transistors. But first we are going to suspect that part. And we can also try to swap the leads around to see is the reading the same. Yeah, it is both ways same deal. So now I think we have to figure out the easiest way to try measure that rectifier part. I don't know is the amp open case behind or not. It is not. So basically it means that we have to take it apart and raise that PC port out of there, that we can continue our trip. Of course, if we want, no, we don't have to. I was thinking that we can measure the amplifier, the transformer leads there, but it don't matter because the fuse blows only when the relay is engaged. So the fault is somewhere here and not there. Yeah. Let's try to take it apart and see can we fix it. I got one idea before taking apart, that we can do the measure more about the diode rectifier. So that we have to engage the relay to get road through to try to measure there the rectifier. But the fuse blows if the power leads are connected, but there is a connector there what we can take off, like that. So now we are not feeding the power to the circuit, but if everything works, the relay will still engage because there is that another power going in which engage the relay, and we can measure through the PC ports directly to measure that diode rectifier more to see are these lines also shorted out. if we want to do that, we have to change the fuse because it is bad. There, the tiny glass thing. And it is 2 amps. We could use our multimeter here to measure the current, but if there is a shortcut or short somewhere, it will blow our fuse in the multimeter. And it is not fun. So it is kinda nicer to blow the spare fuses somewhere else and not our multimeter. There is new 2 amps going in, and let's put our meter just for fun to here to see what the transformer is outputting when we try to plug it onto AC voltage. I heard the relay and we have 11 volts. But I don't know how. How it will turn off. Or on. Let's see what kind of power we have here. Our amplifier side of the unit. 32 volts. It sounds good. And 32 volts. Yeah. And is it 16 there? Yes. So the transformer is good. The power is going in. But I don't know, because I'm not sure is the unit on or off, because I can't find any power button on it. But I heard the relay, so I can only try to believe that the power is connected on the relay. And now I am trying to measure through the relay there to rectifier input. And we can try to measure that diode. Or then see is the 2 lines shorted out first. Maybe we should first check that. Let's say that is maybe worst case scenario. But how I am going to feed my probes lead there? There is kind of a little bit tight now. But let's still try. First probe is there, and the second is there, and hard to see, but the multimeter is showing no voltage, and there is no short circuit, but we don't know, are we now measuring which way the circuit? It is impossible to know. But it shows OL. So there is no way the power can pass like that. But let's try to measure individual diodes. Where is the right one? There is positive. No. No. So we have no way the power get either through that diode or that diode. It means both of these diodes are dead, or then the relay is not connected. Because it is kind of odd, because there and there we measured at 0 ohms. So it means that this and this have to be shorted out, or this and this. What do we do? Or how we turn the unit on? Yeah, I did a kind of offline digging, trying to figure out what the fuck is happening here. So here to here we have a short, and that relay is opening contacts, so they are normally closed. So there is that relay, we can see perhaps on the camera when I plug the plug in, it kinda instantly get energized and it will kind of disconnect the power from the another electronics. But when I am trying to measure the diodes to here, every measure is only half on a volt, 0.4 or 5, and it doesn't matter which way you are trying to measure out, the result is always the same. And it is kind of not normal, because the normal diode behavior would be that conducts only one way and don't pass the another way. But I was reading the papers and figured out that that part what I am working is power supply, and it is generating all kind of voltages. There's something more. There. So the power supply is making 5 volts, 8 volts, minus 13 volts, 12 volts, 28 volts, 14 volts, and the last is there, negative 14 volts. So the fault will go a little bit deeper because we have a short here, so we have to be some kind of fault somewhere here. I was thinking that fault might be between the 14 volts rails, because the negative 14 volt will go directly here, and positive 14 volts also goes directly there, where we measured that short circuit. So I think I have to go to bed because the clock is kinda late and brains really don't work anymore how they supposed to work. But now I am betting the fault between these two lines, and it is basically use that voltage to drive the amplifiers. That negative 14 volt is taken in to amplifier in the right channel, and it should be taken also in the left channel, but I couldn't figure out how, because the drawing is kind of funny. There is only a simplified box because the left channel is identical with the right channel, so it's kind of boring to make circuit diagrams both of them. But that one wire, it's marked 12, is going somewhere, and I couldn't find any place where it might go. But I can assume that left channel will also take in the negative 14, and where is my positive line? There, positive 14. So maybe the fault is either left or the right channel itself. But that we can get our hands to amplifiers, we have to kind of start digging, because they are like the lowest PC ports in the unit. So it is kind of hard to get there. And I'm tired. So let's end that part here and continue to work maybe tomorrow. But if you watch it so long, so thank you for watching, and perhaps we see really soon, because the edited video won't have that my sleeping time included it. So I'm going to sleep now, and soon we will see again. Oh my god. Check this shit out. It is hinge. You can flip it down, then just lift up, and boom. Really awesome. Nice engineering. And what next? I think that plastic thing have to come off now. somehow. Okay, now we have a little bit more things to visible, and as far I can say, I'm not first one inside a unit, because there is fucking a lot of that white conch, kind of mess it up. So somebody have been here before me. And resistor has a little burn mark is under it, so it has to be really hot. Maybe we have to investigate that. But before that we have to kind of figure out how the amplifier is laid down here. These sections look to me kinda identical. So this might be example left channel here, and this might be the right channel here. But what is happening here? Hello, here again, and it has been a little bit time passed, but we have something what we can start to look better. So there is output from amplifier which goes to speaker terminal, and we have two main transistors, and they are between 14 and that lower one is minus 14. There, minus 14 volts rails. And if I measure the leads of transistors, we can see that there is a little bit trouble of there. Because if I do that, it is half a volt, and another one is different, and there is a half volt and half volt, no, 0.8, but it was to base to collector, but the base to emitter is 0.7 volt, 0.4, and there is odd number. Last time I checked it was different numbers, or then I remember wrong. It is shorted to collector to emitter. That tranny 2 shorted, and I can do the test. Reference measure from that channel, I don't remember, this IC 201. So IC 201 there is 200, and that one is 201. So that amplifier is right channel, because the left channel is simplified circuit. So the right channel is working. Sorry, not focused. So the right channel, you can see right channel is good, the collector to emitter line, but the left channel is not, it is sorted. And the short is between collector and emitter, meaning that they are not labeled. They are not labeled the circuit. I have to check out the datasheet to figure out how the leads are going. I don't remember which lead is which. But still, in these components we have a sort, and that we can do something about it. We have to take off the PC parts itself from its housing. And because it is kind of quality product, I think I can predict that it should be kinda really easy task to do. Because it seems to be that everything is reasonably modular. So it is kinda mostly just unblocking the connectors. And when we have the PC port out, we can try to look further what is the real fault. Is it a transistor board, the transistors, or something else? But it is kinda easier to try to figure out when we remove it. What am I missing? There's one screw hiding. How about now? Yes. It must be a best amplifier kinda layout what I have been seeing. It's so modular. It's really nice to work with it. And at this point we can easily see that the amplifier transistor package, the casing, is different. So somebody has tried to do something to it, or then just another channel is fixed before and now another is blown or something. Oh, there is a batch wire too. There is the PCB trace gone, and it is kinda hardwired. Oh my god, it's really horrible job. How the fuck that is so bad looking? You see here, there, and there is not, but there, basically everywhere is some kind of fix done. But why? It really seems that the amplifier is ready to die, and it don't anymore want to repair, but fuck it, we don't care. We are trying still. Let's try first and identify our amplifier transistors. Fix. Okay. They all are a little bit different. But I think we should replace all the heat transfer thing. It looks really old and bad. should come off. There are kinda blow marks. Really nasty. We have to clean it. I think that is broken earlier because the heat sinks look like that. Oh yeah, and the PC part too. If we watch it. It has been bad time when it has been blown away. But I think it's now measures right. But these are not. I think the easiest way is just desolder transistors and see if they measure bad when they are not populated in the board. Then the board itself look at so bad. I have to investigate with microscope and kinda fix it. It is not nice looking. And it is even possible that the repair work here is gone wrong. It is possibility too. Perhaps I first investigate it with microscope. I took it both channels of the board and if the markings are right, this part was IC200 and that was IC201. So IC200, that one is NPN transistor and 201 is PNP. But if we just cross-reference these, because these are the same and they are same. So it is left channel and the right channel. And if I just measure with diode mode collector to emitter line, dead short. And same part in here is good. That transistor, dead short. That transistor is good. And if I swap the leads, still dead short. Good. Dead short. And nothing. So I need new transistors. But why they are bad? I think it is not so easy task, because as we can see in the PC board, that channel has been broken earlier, and now it has a working condition ICs. But the another channel, I think, is not so bad looking, but they are still bad. So what is causing the transistors go bad? It is the real question. I can change the part, but it won't last long if there is some kind of brutal malfunction somewhere what causes the trouble. But I'm not doing it today, and we are kinda calling the repair off at this point and continue again when I have time. For that, but it is kinda weird. It is possibility that they are driving too loud, too low resistance speakers, what is causing the transistor failure. And it has been fixed one time, and then the failure come back. So maybe they were thinking that it is not worth to be fixed because it will fail again, but it might be possibility that speakers are the trouble. Why these fail? We have to investigate it a little bit more, but not now. I'm going to bed, and we can continue the project later on. Hey again. Because the channel MOSFETs or transistors was bad, and my local store has kinda equivalent parts what should be okay. I decided just first swap the transistors and see what happens before digging any further to this board. And the casing is a little bit smaller, but I think it is not going to be a problem. We can perhaps easily get away of it. you can try to pet something. Is it only transistor fault, or is there something else? Something else. What is breaking the transistors? I don't know, but I am willing to try. Yeah. Let's try. Yeah. This really nasty board, but maybe Vintage audio it is not kinda competition for prettiness. And the last time we had a kinda short there where the AC power comes in. Oh, now it is mega ohms. So the problem is maybe solved now. Or then it is something else and I am just kinda ignoring it. But who knows? This is cool. I just can't get over the hinge thing. So cool. So super. And the heatsink supposed to go there, but I am curious to see what happens before I am putting all back together. So that's why I am not right now putting the heatsink on. I am just trying to see if there is something more to do. Yeah, now it went back. There. There. Almost done. And we should put something under here because the heatsink supposed to kinda lift the PC port up, so it is connecting to ground if there is no insulation. Yeah. That's bad. Where I am putting the caps. Maybe there. Or there.
Okay, what will happen? What will happen? Everything is still good. Yeah. No fuses blowing yet. Let's try to turn it on. CD. Yeah, it is better than last time. I can't really now show you, but the unit is doing something. We have lights and everything. So maybe now it's time to try put an oscilloscope to output of audio signal. And then we can try to feed some audio in. And perhaps we can see if the amp is working. Yeah, dummy me. I was kinda speaking here with myself before I noticed that the camera is not recording, so you couldn't really much hear or see nothing, but I decided to clean the heatsink and put it back, and then we can put the amplifier a little bit more back together, measure the voltage rails, and if everything is kind of good in power supply term, then we can try to feed some signal in and see what comes out. And I tried to tell that the thermal compound is good to have, but if it is too much, it is too much. It won't help you at all. and it might be just doing things worse, because it is kinda supposed to have only thin layer between the heat source and the sink, and there we have kind of double insulation because we have those electrical insulator discs here, and then someone have put that a lot of that white gunk, so it is possible that the amplifier is just overheated because the heat sinking is kinda fucked. But let's see. And because we have a circuit diagrams, we can measure the rails, and oh, there was the insulator. We can measure all the rails and kind of try to figure out are everything okay or not before really starting to see what the amplifier is doing. Yeah, it's better now. Then we have a little bit cleaning here. Here. And where? There. Clean that. Oh, awful amount of thermal paste. And these are kind of power supply transistors, and those what we changed are the main output amplifiers. But how it was yeah, it was like that. There. One screw left. Oh, I messed with the screws. That one goes there because it has a smaller insulator ring. Yeah. I think we are good now. Now we can try to put the electric insulators and they are kinda double things because they are also transferring the heat. They just need to be put pretty damn precise that they can work. It's kind of tight fit there to get. Oh, I almost forget. There is there little fellow. There we want to put the thermal compound. That kind of white gunk. But how I am going to apply it under there? I think it might be kind of best solution to put it there first before you do anything else, but we can try. Yeah, it's there. Now the another one. Yeah, we did it. We managed to put it there where it is needed. But I didn't see any kind of springs what will hold the tiny transistors there. So I am not really sure what is holding them there. Let's try. Let's try to bend it a little bit. If it will leave room for that tiny transistor. It's not funny. Not funny at all. But now I made it. Yes. Pretty awful designing. But maybe it is working. But not really user friendly. And now it is needed to make again. Yeah, there is kind of fucked up looking. It's really tiny clearance here to here. So maybe we have to little bit check the resistors after we put all the springies and the insulators on. Yeah. Now it's going. Now it is going back together really well. Soon it will be the moment of truth. Yeah. I will like rewind it because it might be kind of boring to watch. Yeah, it has been again another day because I had another things to do last time when I did that amplifier thing. So now it is another day again, but let's try to kind of get something done. It would be nice to see if Amplifier is putting some audio signal out. Okay, there is that kind of trick. PC port, and it is going like there, and the metal clip is going on top of it. Like there. Yeah, it's good. It would be a great idea to do these kind of stuffs like one day to start to finish, but sometimes you have something else to do, so you have to kind of stop whatever you are doing and continue it later. Maybe you don't have a parts what you need, or then you just have something else to do. And yeah, this is not my work. It is only a hobby. So I don't have perhaps all the pro tools or information for myself what could have some kind of professional dude, but I can do something. And the last one goes there. Yeah. Heatsink completed. And now we can continue to assemble the unit. And test more of it. There is the amp. And here comes the board. Yeah. Here are screws. One, two, three. Where all screws are going? I don't remember anymore. One is coming there. There. What now? I have a couple more. Oh. One screw left over. So what the hell? Oh, or not. It is that. Normally you don't have any leftovers. Yeah. And now it might have a good idea to little bit check how everything is laying down here. To prevent an accidental shortcuttings. Yeah. There is another one. Is there a room that I can try? If I lift the resistors kind of upwards like that. And there might be a little bit more clearance. But I don't know, are these original fittings? Or are these somehow already fitted parts? Because if they are original, they are really odd looking, because everything else is kinda nice and straight. But these don't.
I'm not sure what the deal is there. But I don't want them to be able to touch anything. Yeah. Not good, but maybe it is alright. Let's check these ones, because they look a little bit suspicious. Cool. It is what? 4.9, and it should be the same. Hard. Yeah, they are good. Yeah. Then we can hook this up to power and try to find all voltages here. We can try find that 14 volts. Every one of them. So that 14 volts should be end of diode D10. That will be measured directly in the capacitors, and that is maybe there. Yeah, let's check them all one by one. So first one is that, and it is D10 diode, and it should be almost directly behind the transformer. There is the relay, so it is after the relay. So it should be really easy to find. D10 diode. Where is... I thought that
I am not never going to find that D10 diode, but it is there under the wires there. So it will be our first point to check. Put the multimeter there. And it should be that 14 volts. Let's see. Am I able to probe there? Yeah, it showed 45. Yeah. And it is rectified. So it is good. Next trip will be that it is already rectified 14 volts what we are using in the amplifiers, and that can be probed positive lead of the capacitor. So I can put my probe to there and then we will see what is there. Boop. There's kind of no power, but we can try to power amplifier on. Yes, 14 volts, it's good. Now I shoot it down so the voltage goes low. Then we are going to find 28 volts, and it can be found transistor
2 output leg. Where is transistor 2? There is TR1. Oh crap, it's there. It is kind of tight spot. Maybe it's easier to read out. Maybe the resistor 48. Resistor 48. Where is it? Where is it? $41. $44. $49 is there, so it is somewhere nearby, I think. It is there. That one. There. There is 14.8. And we was finding 28 volts. Let's try the power on. A little high, but it's kind of near what we was looking. What else we want to check? We have 12 volts rail, and it has really various places where it can be found. Let's see, can we found resistor 15 or C9? 15 or 9.
Resistor 15. There's 9, 16. There. And C9. Oh, you can see. There is C9, and under it is that resistor. Resistor 15. And what was that what we were looking? 12 volts. 12 volts. Let's see. Yeah. We had a voltage. So maybe it's time to check. Do we have that negative voltage? So negative 14. It can be found on the capacitor bank. Maybe negative 14. Yes, it's good. Then negative 13. It can be found on resistor 29. R29. Where is it? There is R28. And there, that one. That is R29. But what we was looking? Minus 13. What we have? Why it is showing positive? It should be negative. Oh, our ground lead. Yeah, it is different potential because we was first measuring all the things what is behind this transformer, but that one minus 13 is coming through that transformer. So we have to swap our negative lead to there. let's try that one. It's now showing negative. Seven. Yeah, I think my lead is wrong place still. Yeah, my lead was before. I can show you what dumb move I made. I put the negative probe to here or here, but it's supposed to be after the D3 rectifier. So that my negative lead place should be, it is D3 and that is marked minus. Let's try it out. There is minus and there is that resistor. We are not getting nothing. Where we can find another place to grab it. Or can it even be? Can it be negative voltage after all? Because there, when the power is on, the AC power is going directly to rectifier, and of course there will be our negative point in rectified power, and the output of diode rectifier is of course just positive rectified power. So I think there is false marking that can't be negative power. Yeah, it can't. It should have a positive. And that is what we measured. So it is mislabeled on the circuit diagram. So now we can continue to find that 8 volt rail and 5 volt rail. 8 volt is coming TR12. DR12. it is there. So there should be outputting 8 volts. Okay, it is 14. Close enough. But I don't really know why they are so much higher than they are labeled. Or maybe it is that way. Because in the transformer it is marked that it is originally wired 210 volts coils, so it is kind of hooked 220 volt input range. But here in Finland we have 213 or more, so we have at least 10 volts over voltage to input side, and I think it is correlating to output. It would be safe if we hook those 10 volt extra inputs to get the power matched. Perhaps it is a reason why the amplifier is broken, because we have too much power what we are feeding in. Welcome back. I have been so busy that I didn't have time to finish that project, but now it's time to finish that thing. And it was impossible to use the amplifier without a remote control or that really sleek BEOSYSTEM's super master control panel thingy. So I need to first get these ones that I can continue to testing. But here is kind of simple setup. I'm using a simple function generator in my phone, and now I have been set 414 Hertz to frequency, and that is signal what we are going to feed in like that, and there we can see the signal and exactly 414 Hertz. And if I am using the remote controller to lower the volume or rising it up, it will amplify that signal higher and higher, even so high that it can't anymore fit in my scope screen. Let's see how big that can came if we kind of boost up a little more, bit more volume. We can do more. Yeah, now it is maxed up, so it's showing peak to peak voltage for the signal 15. Yeah, 15.5 volts. And we can change the frequency if we want to see how the amplifier is responding to inputted frequency, let's say 15 Hertz. Or can it do lower? Hertz. Let's try 10. Yeah, trouble triggering, but really nice response. Yeah, but it won't anymore kind of amplify. 2 Hertz is too low. There it starts amplifying from 7 Hertz. And there is kilohertz range. There we are feeding 6.57, 6.58. Or then we can try white noise. Yeah. And it seems to be now pretty much working unit. Of course, it might be a good idea to test it with speakers and real audio, but maybe after that, when we put all back together. And that was really sleek. It shows volume range, volume, and what input is selected, and we can dial the volume down. It's really cool. Yeah, but unfortunately I don't have the whole unit. Here I have only amplifier and remote controllers, so we can't do whole system testing thing. It is kind of shame, because the whole system is kind of really cool looking unit. But you can watch internet if you want. What is that system? And now what is left for us is only to put all back together. And of course deliver the amplifier back to
its owner. And I think there is not much to see when I am putting it back to one piece, because at this point what we have only one plastic thing to be put back and these caps on it, so it is kinda maybe boring or not interesting, let's put it that way. But if you want, of course I can keep the camera rolling, but I will be really much impressed if even one person will look the video till the end. But yeah, the fault was the transistors. These fellows. Whoop. And they are just identical for each channel. Left channel has 2 of those and the right channel has kinda identical parts. In case you want order the spare parts before taking the amplifier to parts. And yes, I have been thinking a little bit what is caused the amplifier to break, and I have no idea. It's not quite fitting there now. Because of that is hitting the resistor. It will barely fit. Barely it will fit. but I'm pretty sure that the resistors are not original parts. Somebody have been changing them before I get the unit in my hands. Yeah. And yeah, I didn't. Oh. It's not good. I tested the fan circuit, that the fan was spinning freely, but now it is not anymore. It was good to test, because if the fan is stucking, it is not blowing the cooling air to here, and it might be causing the transistors to fail. So it was good thing to test. Oh, they are so tight. Tight capacitors. Let's put them back in the plastic pack. And let's rise that part back. And let's try. It's better. Now it spins freely. Let's see when we put back the plastic thingy. What happens? It is rubbing, but let's put the screw and then see. Oh. Now it's good. Yes! Now it is not rubbing anymore. Now we can re-enter the capacitors. Or reinsert. The fan is spinning. It's good. Then everything what is left anymore is these screws. And I have to show you, it is really sleek. It is the child toy cup game thing, where you can stack the cups. It is really nice little trays for disassembling something, because you can do one stage, and if you are taking it apart more, you can put more next stage parts there, and then you kind of get all the screws organized, and it is taking really small place in your desk when you are not using it. There is the screws, and how many? There are 5. 1, 2, 3, 4, and 5. Yes. Right amount. Not too much, not too less. And because the screws there is happening something funny. It is not fitting perfectly. There is something underneath blocking the PCB way. But what? Yeah. Now it is firmly in the right spot, and no cables are stuck anywhere. But now I have kind of problem, because I don't remember how that part was there. But if I have to guess, it was that way. But I have to check
check it from the tear down, for the tear down feed when I take it apart, because I don't remember was it like that. We will be back. I will check the footage. Yeah, it was like that. I remember it right. Sometimes it is kind of hard job, or at least it is really like a job when you are trying to make a video about what you are doing. It takes time and makes all repair things. Oh, there is, if someone is interested, the what is that called? That kind of information sticker. What we are and how much we have power, and some kind of patents, perhaps 85 and 87. So yeah, old indeed. But sometimes old is better than new. Or at least we can try to think about that way. I think the cable is not, it is not supposed to come here. There must have some kind of misconstruct. I'm pretty sure that the cable should have its own slot. But because the amplifier came already in opened condition to me, I don't have the screws. Why it's not sliding to its place? Oh, I don't know. And I think it is not my problem, because I haven't taken it fully apart. And I don't have the screws either. It would be really nice if it will slide whole way. But I am not now. Oh, but there is no screws at all. So the thing will somehow snap on. Oh, there it will be stuck. How we can we will put this thing down. For bending it is only thing what comes in my mind. Now it should work. Let's try again. Yeah, now it's sliding. Now it is going. Yeah. I had one screw a little bit high. That's why the cover didn't go in the right spot. Yeah. It is done. Thank you for watching. Stay safe and have a nice day. And if that was even a little bit interesting, please leave a comment that I will know
will I do more these kind of troubleshooting videos, or what I will do in the future. So, thank you for watching and have a nice day.